So we have chosen the programming language. Now comes the next question. Where do we begin? Because learning to program and teaching programming are two very different things. You can learn almost any programming language by following a good book, an online course, or a YouTube tutorial. Search for how to code and you'll find hundreds of thousands of videos. Most of those courses follow a carefully planned structure. As the learner, you simply follow it. You don't really notice the structure. As the teacher, you have to understand it, because a large part of teaching kids to code is deciding what learners should discover first, what should come later, and how to stop everything becoming overwhelming. That's exactly what this course is about. We're going to learn to program together while also exploring how to teach it. Sometimes we'll zoom right in and explore a programming concept in detail. Other times we'll zoom right out and look at the bigger picture, because sometimes understanding the journey is just as important as understanding the destination. I'm filming today's episode here at the Clent Hills. I have been walking these hills since I was about 3 years old. I know where every path will take me. I could design a 20-minute, 60-minute, or even a 2-hour walk purely from memory and experience. A beginner taking their first steps on the Clent Hills today would probably look at the map, or they might have prepared a route at home, or they might just wing it and hope that they don't get lost. A beginner and an experienced walker will have different approaches for getting from A to B. We can take a similar approach to programming. A really experienced programmer doesn't just see the lines of text. They have a rich mental model built up inside their memory, an invisible, intuitive map of how a computer behaves. Because they have this mental model, they instantly recognize familiar code patterns. These patterns are like reliable routes or blueprints that can be applied to lots of different scenarios. To see how these mental models work in action, let's leave the hills for a second and look at the screen.
Let's say a programmer decided they wanted to build a project with a magic cube. They know what they want the computer to do. Now they need to work out how to make it happen. First, they'll need a world. Then they need a cube. That seems like a good place to start. Next, they decide that they want to make the cube glow, so they go looking for that block. Then they decide actually they'd like the colour to keep changing, so now they need something different. Then they think it would be even better if it only changed colour when clicked. Again, they go looking for a different piece of code. As their ideas grow, they call on their mental models to choose the right code patterns to make them happen.
If an experienced programmer has an idea but no mental model to guide them, they've built up a great set of tools to help them find a solution. The tools are grit and resilience, which are just as important as the programming concepts themselves. They get better because they have an idea, and they will sit and problem solve until that idea is realised. But here's the challenge. How do you know what to look for if you don't yet know what's possible? If you don't have any mental models? That's where starting with the big programming concepts comes in. The programming concepts are like puzzle pieces that fit together. Each one helps you solve part of the problem. For many years, people have talked about three foundational programming concepts: sequence, selection, and repetition. Sometimes they're called the big three. Sequence is putting instructions in the correct order. Selection is making decisions. Repetition is repeating instructions when you need to. Because FlockXR is an event-driven programming language, I actually think there's a fourth concept we should include: events. Events answer one simple question: when should this happen? When the game starts? When a key is pressed? When an object is clicked? Those are all events. So for this course, I like to think of them as the big four: sequence, repetition, events, and selection. That's the start of the journey we're going to follow together. If I were teaching young people with FlockXR, this is the exact order I'd use. It also works brilliantly in Scratch. Events make programming exciting very quickly. With just a few blocks, learners can already build interactive projects that respond to them. If you were learning Python, I'd probably structure things differently. Python can absolutely use events, but first you usually need to become comfortable with the syntax or the precise text, grammar and spelling rules of the language. FlockXR lets us focus on programming first, which is much more interesting to me. Sorry, Python fans. Next time, we'll explore the simplest programming concept of all: sequence. It sounds straightforward, right? But it turns out it's one of the most important ideas in programming. I'll show you how to teach it, the common mistakes learners make, and some simple projects that bring it to life. If you'd like to follow the whole journey, don't forget to like and subscribe. And I'll see you for the next episode. Bye bye for now.